Technology and pray as we are having a seat. My Lord, spiritual and temporal, members of the academic community, great Rotarians, ladies and gentlemen, you are all welcome to the 191st Inaugural Lecture of this great university, titled Wonders of Weather in a Polluted World, to be delivered by Ayodeji Oluleye, Professor of Air Quality Forecasting and Climate Change. In tandem with the tradition of our university, this inaugural lecture will be chaired by our Vice Chancellor, Professor Ayodeji Oluleye. She's ably represented here this afternoon by the Deputy Vice Chancellor Academic, Professor Timothy Taiwo Amos. You are welcome. We also have our other principal officers here with us. Professor Sunday Samuel Oluyamo is the Deputy Vice Chancellor of Development. Mr. Charles Olusegun Adeleye is our Registrar and Secretary to Council. We also have in our midst our bossa, Mr. Peter Oladapo Oshadipa. Also, the librarian, Mr. Robert Agiade Awoyemi. We have in our midst our deans of various schools, ably led by the Chairman Committee of Dean's Futa and the Dean School of Computing, Professor Boniface Kayode Adeshe. Professor Akim Oladekon, Professor Olabode Thomas Adebayo is the Dean School of Agriculture and Agricultural Technology. We also have in our midst the Dean School of Basic Medical Sciences, Professor Akim Oladekon Lawal. Professor Christopher Oluwakumi Akimbile is the Dean School of Infrastructure, Minerals and Manufacturing Engineering. The Dean School of Electrical Systems Engineering is Professor Adegoke Oladipo Ebeji. We have Professor Joseph Omoni Ibashomu, the Dean School of Environmental Technology. The Dean School of Logistics and Innovation Technology is Professor Olayemi Olaseyinde Samuel Oke. You are welcome, sir. We have the Dean School of Life Sciences, Professor Muftau Kolawole Oladumoye. Also in our midst is the Dean School of Physical Sciences, Professor Femi Barnabas Adebola. We also have the Dean School of Postgraduate Studies, Professor Oluwayo Bello Olusoji. While the Dean that controls the largest constituency on campus is the Dean Student Affairs Division, Professor David Olariwaju Oke. Once again, I would like to introduce to us the inaugural lecturer of today. He's also the Dean School of Health and Mineral Sciences, Professor Ayodeji Oluleye. Right now, I would like to invite to the podium the representative of our Vice Chancellor, ably represented by the Deputy Vice Chancellor Academic, Professor Timothy Taiwo Amos, for the VC's welcome address. You are welcome, sir.
Introductory remarks by the Vice Chancellor, Professor Ayodeji Oluleye, FAS, at the 191st Inaugural Lecture delivered by Professor Ayodeji Oluleye today, Tuesday, 27th January 2026, in the Obafemi Awolowo Auditorium. The Deputy Vice Chancellor of Development, Registrar, and other principal officers, my Lord, spiritual and temporal, top government functionaries here present, our inaugural lecturer of today, Professor Ayodeji Oluleye, deans, directors, and heads of departments, distinguished members of Senate and Congregation, eminent scholars and friends of the university, gentlemen of the press, distinguished ladies and gentlemen. I'm here standing in for the Vice Chancellor to give these introductory remarks. So, whatever errors that you may find is mine, but I will read as she has put it. It gives me great pleasure to welcome everyone in the 191st Inaugural Lecture of the Federal University of Technology at Futa. I welcome very specially our spiritual and traditional leaders, top government functionaries, captains of industry, friends of the university, and the entire staff and students of the university. I'm very pleased to welcome the immediate and extended family members, friends, and well-wishers of the inaugural lecture. I felicitate Professor Ayodeji Oluleye on this academic milestone. I was told that we have to go stage 3 times. So he now corrected that actually it's going to prostrate 4 times. May I at this juncture request the inaugural lecturer to please rise while I present the citation. Ayodeji Oluleye was born on the 9th December 1975 in Ijare, the federal local government area of Ondo State. He attended Anglican Grammar School Ijare, Ondo State between 1988 and 1993. Subsequently, he came to the Federal University of Technology, where he got his first degree, master's and doctoral degree in meteorology and climate science. Ayodeji Oluleye joined the services of the Federal University of Technology as assistant lecturer in the Department of Meteorology, School of Earth and Mineral Sciences since in November 2005. And was appointed professor in October 2021 in the same department. He has served and supervised over 100 undergraduate projects, 45 master's dissertations, and 8 PhD theses. He has authored and co-authored several other journals in reputable peer-reviewed journals, and has presented papers at several conferences both within and outside Nigeria under the auspices of the American Geophysical Union Conference, United States, the European Geosciences Union Conference, Austria, and several climate and environmental science conferences in Germany. Professor Oluleye belongs to several professional bodies. Very importantly, he is a member and currently the treasurer of Nigeria Meteorological Society. He also serves as reviewer of several national and international journals, notably Journal of Climate, Theoretical and Applied Climatology. Professor Oluleye has had years of experience both in lectureship and management positions in the university system, and has served the Federal University of Technology in many capacities, such as member, Senate Curriculum Review Committee, Associate Director, Center for Continuing Education, Subdean, School of Earth and Mineral Sciences, Chairman, Senate Quality Assurance Committee, Scientific Coordinator, West African Science Service, Center on Climate Change with Children. In a world of increasingly,
Vice Chancellor, Deputy Vice Chancellor, Academic and Development, Registrar, other principal officers of the university, deans of school and directors of state, heads of department and units, member of state, member of the University Council, past and present, my lords, official and temporal, Royal Majesties, distinguished professors and colleagues, students of the School of Art and Liberal Sciences, distinguished guests and friends of the university, my immediate and extended family members, gentlemen of the press, ladies and gentlemen, great children. On Tuesday, 9 December 1975, I appointed the family of Mr. Julius Oluleye and Mrs. Next Oluleye for our hospital in my academic journey commenced when I enrolled as a teacher Anglican Primary School in Direct during the 1981-1982 academic session. I proceeded to Anglican Grammar School in Direct in 1988, where I completed my secondary school education in 1993. In 1995, I made admission to the Federal University of Technology Akure to study meteorology. I graduated in 2001 as a graduate student of the department. In 2003, I was awarded the Federal Scholarship by the Federal Government of Nigeria to pursue a master's degree in Industrial Environmental Management at the University of Ayodeji, Scotland. Upon my return to Nigeria in 2005, I joined the Department of Meteorology as an external lecturer. I subsequently obtained my Doctor of Philosophy degree in the same department in 2012. By the grace of God, I progressed through the academic ranks. I was appointed professor in 2021. I was further honored to become the first undergraduate alumnus of the School of Art and Mineral Science to be elected as the dean of the school. Over the years, I have actively participated in several notable research projects within Nigeria and internationally. Most recently, in 2023, I served as a research scientist at the Institute of Atmospheric Physics in Germany. The foregoing represents a concise summary of my academic journey to date. It is with deep sense of humility and honor that I present to you today the Inaugural Lecture titled Wonders of Weather in a Polluted World. This 191st Inaugural Lecture of the University is the third in the Department of Meteorology and Climate Science and 13th in the School of Art and Mineral Sciences. Madam Vice Chancellor, weather in its ceaseless motion is both science and poetry, a symphony of forces that inspire curiosity as much as it demands comprehension. The scientist in the cloud, the process of condensation pressure and the temperature gradient. The poet sees in the same cloud a messenger of promise or warning. Both are correct, for the beauty of weather lies in its duality, its periodic precision, and its emotional resonance, dynamic atmosphere, a living system. The atmosphere, though it is part of the atmosphere, dynamic and inspiring system. It is the protective envelope of gases that sustain life, shield planets from harmful radiation, and drive the wondrous phenomenon of weather and climate. Despite appearing boundless, the atmosphere is integrated. Nearly 99% of the planet is contained within the first 30 kilometers above the Earth's surface. As shown in Figure 1, the structure is stratified into discrete layers, each characterized by unique temperature trend, composition, and physical processes. Understanding this layer is essential to grasping the interconnected system that shape weather, climate, air quality in a polluted world. The troposphere is the newest layer, extending from the surface to about 8 km at the pole and up to 18 km at the equator, due to thermal expansion. It contains approximately 75% of the total atmospheric mass and almost all of its water vapor. This is where cloud form, wind blows, and precipitation occur, the true theater of weather. Temperature in the troposphere decreases with altitude at an average rate of 6.5 degrees Celsius per kilometer. The phenomenon known as environmental lapse rate. The particle gradient rise from pressure. The rising of warm air and sinking of cooler air, which fuels storm and weather system. The upper boundary layer, the upper boundary known as the tropopause, acts as a limiting cap, limiting particle mixing. Its rise fluctuates with latitude and season, rising higher in tropical region where convective activity is more intense. From a pollution perspective, The troposphere is always where most human active solution accumulates. They also particulate matter, ozone and nitrogen oxide interact dynamically with meteorological processes influencing both weather and climate. For instance, thermal diversion, where temperature increases to side, can trap pollutant near the surface, leading to small episodes in cities such as Lagos, Nairobi, and Johannesburg. Other layers are the stratosphere, which is the ozone sheet, mesosphere, which is the meteoric layer, thermosphere, and exosphere, which are the frontier of space, the border and vertical body. Each atmospheric layer is testament to balance and design. The lower layer measures life and weather. The middle layer protects, and the upper layer connects our planet to space. Together they form an integrated system that regulates the energy flow, shield against possible hazard, and sustain the biosphere. As humanity continues to alter the composition of the lower atmosphere through pollution and greenhouse gas emission, this delicate particle mode faces unprecedented stress from tropospheric flow to stratospheric ozone recovery. Understanding this layer is not mere academic. It is essential for managing our future climate, health, and environmental security, climate change, and weather extreme. Climate change is not merely an environmental issue. It is the divided challenge of our time. The atmosphere was the silent guidance of balance, now echoes the consequence of human action. Heat waves, floods, droughts, and storms are no longer distant anomaly, but the occurring reality. For Africa, a continent already living close to the margin of climate vulnerability, the implications are profound. Yet, within this challenge lies an opportunity to advance science, strengthen animal systems, and foster sustainable adaptation rooted in indigenous knowledge and technological innovation. The wonders of weather persists, but they now carry a missionary message. Our stewardship of the atmosphere determines the legacy of climate for generations to come. Humanity stands as a divine moment in its relationship with the atmosphere. The warm predictable rhythm of weather are becoming increasingly erratic as the steady hand of climate balance trembles under human influence. The warming of our planet, driven by greenhouse gas emission, deforestation, and industrialization, is reshaping weather pattern and magnifying extreme events across all continents through an integrated link shown in Figure 2. From flood to drought, heat waves to tropical cyclone, the fingerprints of climate change are now etched in the atmosphere's daily scripts. The polluted planet. The chemistry of pollution is really profound truth. Every breath we take is connected to the global web of reaction, linking the kilo to factory, forest to freeways. The decision between national and local emission is increasing law as human activity amplifies and modifies natural processes. In this polluted world, meteorology and chemistry combine to remind us that atmosphere is not limitless. It responds, reacts, and records our action. Understanding this chemistry is the first step toward claiming the wonder of clean air, inherited as vital as the weather itself. The air that develops our planet is not just an invisible blanket of gases. It is a living chemical reactor. Every second, millions of reactions occur within the atmosphere. Molecules collide, break apart, recombine, and transform. This dynamic chemistry governs the quality of the air we breathe, the clarity of our sky, and even the stability of a global climate. The atmosphere natural composition sustains life, but the delicate balance is increasingly disrupted by human activities. To understand the complexity of modern air pollution, we must first distinguish between the natural and anthropogenic emissions. The three sources that feed the chemistry of our polluted world: air quality and human health. Air pollution is both a scientific and moral challenge. Its invisible nature carries deadly issue, troubling life, stunting children growth, and modern economy. PM2.5, PM10, ozone, loss, and SO2 are more than mere chemical species. They are indicators of how human interact with the atmosphere that sustain us. By integrating meteorology, environmental chemistry, and public health, we can develop predictive tools and intervention to restore the quality of our air, the wonders of weather, and the science of pollution converge here to remind humanity that the atmosphere is not an immanency but a shared inheritance demanding stewardship. The air that sustains life has paradoxically become one of the greatest threats to human health in the modern era. Every breath carries not just oxygen, but an invisible fusion of gases and particles that can profoundly affect our well-being. The World Health Organization estimates that air pollution causes over 7 million premature deaths each year, ranking among the leading global health risks. The content of greatest concern, fine particulate matter, ozone, nitrogen oxide, and sulfur dioxide are pervasive across cities and rural regions alike. affecting the norms, art, trade, and even unborn children. The African reality, the convergence of this. In Africa, there is social pattern, even from the slight medium, but the consequences are equally severe. The contents of land is often a mix of exhaust, dust, biomass, smoke, and industrial emission. Rural population faces less indoor pollution from liquid wood, charcoal, or kerosene, and a visible killer can claim 400,000 African lives annually. Studies in Nigeria, Ghana, and South Africa show strong correlation between elevated PM 2.5 level and hospital admission for asthma, bronchitis, and hypertension. Women and children who spend more time near fires are disproportionately affected, facing higher rate of COPD and cardiovascular stress by contribution. Extreme event in the polluted atmosphere. For the Vice Chancellor, extreme event in the polluted atmosphere are reminded of the inseparable link between weather and human activity. Thus, demonstrates nations past power, biomass burning demonstrates humanity influence, and hence symbolizing the complex equilibrium between them. Equal adaptation accordingly have revealed how these forces shape African atmosphere, altering radiation, rainfall, and health outcome. In a polluted world, every storm, every rain pain or face tell a story that the weather we experience is simply a reflection of the choices we make. The earth atmosphere, though dynamic and self-regulating, occasionally expresses its power through extreme pollution events that match natural processes with human influence in these influences across West Africa and much of the tropics. Dust, storm, biomass burning, and haze service to dominate the landscape of atmospheric extreme. This phenomenon blurred the line between weather and air quality. The linear meteorological and photonic forces combine to shape the chemical and radiative balance of the atmosphere. Research for Oluleye and Ayodeji 2009 has significantly advanced our understanding of how these extreme events influence regional climate and air quality. These studies have shown that West African polluted atmosphere is not a passive consequence of emission source alone. It is an active participant in the modulation of rainfall, radiation, and health outcome. Dust storm, the desert great exhalation. The Sahara Desert stretching across North Africa is the planet's largest source of miraculous aerosol. Each year, hundreds of millions of tons of fine particles are lifted by storm wind and transported over thousands of kilometers over West Africa. The Harmattan season between November and March is characterized by intense dust outbreak driven by the northeasterly trade wave. This storm dramatically alters visibility, radiation, and thermal balance. The study of Oluleye and October 2013 documented episode of high erosion of typical depth across northern Nigeria, showing that surface radiation increases sharply during severe dust distribution. The reduced isolation on the surface, while dust layer above the sunlight, warming the mid-atmosphere and increasing atmospheric stability. Recent regional project work of Oluleye and Ayodeji 2024 further demonstrated that dust erosion influence surface energy forces and boundary layer dynamics, leading to temperature inversion that trap over surface. Dust storms are not merely natural events. They act as major atmospheric modifier, altering both weather and air quality across vast regions. Biomass burn, fire in the sky. In the tropical Africa, biomass burn is a dominant contributor to air pollution, especially in the dry season. Fire from agricultural residue, land area, and methane, fuel inject large quantity of black carbon, organic carbon, CO, NOx, and CH4 into the atmosphere. This emission forms thick smoke plume visible from space, stretching across Guinea and Sudan savannah. Through satellite analysis, Oluleye and June 2019 identified clear systematic impacts correlated strongly with elevated erosion loading and reduced visibility. Biomass burning, erosion, absorb sunlight, and warm the atmosphere, thereby enhancing particle stability and reducing convective rainfall. At the same time, the scatter part of the topic solar radiation reduces surface solar losses by up to 20 to 30 volt per meter square. Beyond this, there are radiative effects. Smoke particles, influenced now by microphysics, acting as cloud condensation decline. They increase cloud nuclear number, concentration, and reduce droplet size, often suppress rainfall. The work carefully done by Oluleye and Prof 2020 revealed that each erosion influence induced changes will delay rainfall losses and alter regional precipitation intensity over Nigeria and Ghana. The health burden of biomass burning is severe. Fine particulates and gases cause respiratory inflammation and contribute to prevention mortality. In the past sectors like Lagos, Ibadan, and Accra, the combination of open wall, vehicular emission, and regional smoke plumes frequently pushes air pollution level far above WHO guideline. Thus, fire not seen as a symbol of renewal, now represents the significant atmospheric hazard, warming the sky, polluting the air, and disrupting hydrological cycle across sub-Saharan Africa. Is the event when the air loses its clarity. This is the physical expression of atmospheric stagnation, a product of accumulated aerosolar wind and stable thermal condition in many African cities. This is a composite of local emission, regional smoke, and transported dust. During the Harmattan season, this mixture can create a dense gray atmosphere, reducing visibility to less than 1 kilometer, as we say around us in these days. In a multi-year analysis of satellite observation, Oluleye Adeya 2009 highlighted how this episode corresponds with elevated nitrogen observed and aerosol level, especially over southern Nigeria industrial belt. This episode occurred under shallow missing layer and strong emotional inversion conditions that prevent particle dispersion. This not only obscures sunlight but also water radiation balance by scattering and absorbing short-wave radiation. It cools the surface while warming the atmosphere enough. The feedback reinforces stability and prolonged pollution episode. In cities like Lagos, Port Harcourt, and Abuja, this event disrupts aviation, reduces line efficiency, and accessibility to this threat. When combined with high humidity, aerosol hygroscopic growth further reduces visibility and promotes second formation, including ozone and surface erosion. Thus, this represents the complex interplay between meteorology, chemistry, and human activity, climate feedback, and ocean output. Don't stop. Biomass burning and this event are not isolated. They interact in a multifaceted feedback with the air quality and climate, studied by William and Ocean 2022, show that every aerosol loading during dry season reduces surface latent heat loss and long-wave radiation, shifting of sun rainfall pattern southward. Climate change is likely to exacerbate this extreme. Rising temperature increase fire susceptibility and dust mobilization potential. While prolonged drought and rapid organizations of new emission sources, without mitigation, the frequency and severity of air pollution extreme will continue to rise, threatening food security, public health, and infrastructure resilience. Looking ahead. As climate change continues, heat waves are expected to become longer and more frequent, particularly across arid and semi-arid zones. The pollution leakage observed by Oluleye 2017, Oluleye and 2021 underscored the need for integrated air quality and climate policy. Effective mitigation must address both greenhouse gas emissions and local pollution sources, reducing aerosol reducing feedback that exacerbate drought and heat extreme. In a polluted world, heat waves and drought are no longer purely meteorological events. They are symptoms of a disturbed atmospheric equilibrium shaped by human activities. Case studies, West Africa. Understanding the lessons between air pollution and extreme weather requires examining regional case studies where emission, climate dynamics, and human probability intersect. Three regions, West Africa, South Asia, and China, illustrates distinct yet interconnected pathway through which pollution influences heat waves, drought, and atmospheric extreme. West Africa, dust, smoke, and dry spell. West Africa expresses the complex blend of natural and anthropogenic pollution sources. The Harmattan dust storm, biomass burning, and urban emissions combined to produce intense aerosol loading during the dry season. Ayodeji 2022, Ayodeji Oluleye 2013 demonstrated that this erosion reduced surface solar radiation while warming the lower atmosphere, altering regional energy balances and delayed the onset of monsoon. This suppression of conventional control to prolong drought episodes, especially in Sahel and northern Nigeria. During dry season a year, surface temperature soar while humidity remain low, favoring heat wave conditions. They also reduce atmospheric stability beneath vertical receive, trapping water near the surface. Consequently, the air quality deteriorates precisely when heat stress is most severe. The feedback loop between dust and drought is particularly striking. Drought exposes non-bare soil, enhancing dust mobilization, while dust is self-modified radiation as rainfall. The vicious cycle of urban work using warfare. In coastal cities like Lagos and Accra, urban pollution combined this effect, creating local heat island superimpose on regional warming, lessening across region. West Africa, South Asia, and China share a unified theme. Air pollution and perfect climate extreme. While extreme weather causes pollution and exposure. The research by Oluleye 2004 highlight that addressing air quality is integral to managing climate resilience, reducing rates of not only effect but also can also restore more stable reform and temperature regimes. modeling and forecasting air quality. For centuries, humans have looked to the sky, seeking to define weather. What's the matter of prediction and empirical wisdom? Weather prediction has evolved into one of the most computationally intensive scientific enterprises on earth. The transformation from traditional observation to numerical weather prediction marked the revolution in meteorology. The transition from art to science, from speculation to simulation. Today, the same mathematical framework that predicts rainfall and storm have become fundamental to air quality forecasting, linking meteorology and the atmospheric chemistry in a unified modeling system. This marriage between physics and chemistry allows scientists not only to forecast weather, but also to predict pollution concentration, visibility, human health risk hours to day in advance. In 1970s and 1980s saw exponential improvement, data assimilation technique, satellite observation, and increased computational speed. In Africa, meteorological institutions such as NAMED and WASCA later adopted regional model to simulate rainfall temperature and its event with growing accuracy. In recent years, Oluleye and Prof. 2021 applied workfare to simulate rainfall relation curve interaction in West Africa, demonstrating how biomass body aerosol water precision efficiency and surface energy losses. Such applications underscore how NWP has gone from forecasting rainfall to predicting atmospheric composition and pollution episodes, forecasting air pollution episodes. For the first transfer, operational air quality forecast system based on NWP model now run in many parts of the world. European 21st atmosphere monitoring system produce daily forecast of PM2.5 ozone and NO2 using the ECMWF model coupled with chemical strips. Similarly, in the United States, National Air Quality Forecasting Department integrates WASP and CMAC. In Africa, similar leadership by Maki, Oluleye and Ayodeji demonstrated the visibility of near real-time forecasting of optical depth and relative forces using satellite and model integration over West Africa. This study emphasizes the need to operationalize coupled NWP chemistry model in the region to predict Ramadan dust outbreak, smoke flow, and urban haze episodes, challenges, and opportunities. Despite several challenges persist, sparse observational network in developing region, limit model in its initialization accuracy, uncertainty in the emission inventory, especially for dust and biomass burning, affect forecast reliability, computational cost, high resolution compute simulation, demand enormous processing power and storage, chemical complexity, thousands of atmospheric reactions will be parameterized efficiently. Addressing these challenges require international collaboration and capacity building. Institutions such as WASCA, NAMED, ECMWF, and future departments of meteorology and climate science are key to strengthen regional modeling expertise. The need for regional modeling in Africa. Africa is home to some of the most complex climatic systems on earth. In West Africa, monsoon, the Congo Basin Convention, the East Africa Island, and the Southern subtropical system. This system interacts across multiple scales, generating weather extremes ranging from drought and fog to dust storm and tropical cyclone. However, because of complex transnational network, many of these interactions remain poorly understood. The Jordan climate model, downstream global data set to final resolution typically 10 to 50 kilometers, enabling the simulation of local climatic probability and impact. For example, Congress Africa, initiated by World Climate Research Program, has produced high-resolution climate projection for the 21st century under the multiple greenhouse gas scenario. This simulation provides critical inputs for assessing future changes in temperature extreme, rainfall distribution, and agricultural productivity. In meteorology and air quality forecasting, regional models such as the weather research and forecasting model, RESCM, WASCA are widely used across African institutions. This model has become essential for efficient forecast, seasonal outlook, and air quality assessment in data scarce environment, challenges, and capacity building. Despite these advances, regional modeling in Africa faces significant constraints, limited access to HPC, incomplete efficient inventory, and gaps in ground validation network. The main major hurdles many national meteorological agencies rely on externally generated data set, considering local innovation and sustainability. To overcome this limitation, initiatives such as WASCA, Africa, and AMA projects have been primarily promoting model building, data sharing, and regional collaboration, international and regional policy framework. Globally, the foundation for emission reduction rests on agreements such as the Paris Agreement 2015, which commit countries to reduce greenhouse gas emissions to limit 191 Convention on Climate Change, the Montreal Protocol, and the Kigali Amendment address ozone-depleting substances and short-lived climate pollutants. Africa participated in this global mechanism through regional initiatives like African Regional Climate Change and Resilient Development Strategy 2022 to 2032, and the African Clean Air Program coordinated by UN. This framework promotes low-carbon energy transition, improve air quality monitoring, and the phasing out of high-emission fuel. The West African Clean Cooking Alliance and ECWA Renewable Energy Policy are example of generally tailored intervention designed to reduce harmful emissions, improve energy efficiency, and promote renewable sources such as solar and biogas, national policy and institutional framework. At the national level, emission reduction policy depends on country environmental governance capacity, data availability, and political commitment. Nigeria, for instance, has developed a nationally determined contribution under the Paris Agreement, pledging to reduce greenhouse gas emissions by 47% by 2030. With international support, Israel and Nigeria, they vital role in regulating their pollutants and integrating climate data into policy framework. Research by Oluleye and 2021 have shown that atmospheric areas of environment burning and fossil combustion are major contributors to regional mess and energetic imbalance over West Africa. Such as evidence is valuable in the national environmental regulation, public health intervention, local implementation and capacity building. Policy effectiveness ultimately depends on implementation at the local level, where municipalities, industries, and citizens interact with environmental regulation. Local government can introduce urban emission inventory, low emission zone, public transport, reform to tackle pollution sources directly. Public participation and education are equally essential. When communities understand the impact of pollution, air pollution, they are more likely to support emission control programs that link university, industry, and government, such as those led by Bascan and Nigeria Climate Innovation Center, build technical capacity and promote data-driven decision making, benefits, and policy relevant. Integrating air quality model into WS offer multiple societal benefits, health protection, advanced alert, enable hospital and community to prepare for pollution, reduce hospital admission for asthma and cardiovascular diseases, agricultural planning. Focus of just and scope can inform planting schedule and livestock managing, transport and energy, visibility and air quality focus support emission safety and guide cleaner energy operations. Climate adaptation, coupled model enhances understanding of the interaction between pollution, weather is and climate feedback. In Nigeria, climate collaboration with societies such as Africa and regional framework like PASCA is helping to embed air quality modules into national capacity system, advancing towards a comprehensive environmental early warning network, challenges and the way forward. Despite clear advanced integration faces barrier including limited computational capacity, scarce emission inventory, and insufficient data sharing mechanism. Developing national framework that will make meteorological health and environmental agency will make critical. Capacity building through training program, collaborative modeling projects, and regional data hub will ensure sustainability. The power of low-cost sensors. Low-cost air quality sensors use optical or electrical detection method to estimate pollutant concentration, while they are less precise than reference rate instruments. Advances in calibration algorithm, co-location studies, and data correction model have significantly improved reliability. For instance, studies have shown that properly calibrated low PM2.5 sensors can achieve correlation coefficients above 0.8 compared to reference monitoring. Oluleye and others have emphasized the importance of low-cost sensors in government and African context, where institutional monitoring capacity is limited. The research aligned with Bascan and Alignment Initiative. The integration of sensor data with satellite observation and American model has been shown to enhance early warning system for dust, smoke, and air pollution in future atmosphere. Solar radiation refers to a set of proposed climate intervention techniques designed to reflect the portion of the incoming solar radiation back to space, thereby offsetting some of the warming caused by greenhouse gases. While SRM cannot replace emission reduction or adaptation, it is increasingly studied as a potential short-term way to reduce global temperature rise. The two most discussed SRM SRM method that stratospheric aerosol injection and marine cloud bracking. Stratospheric aerosol injection involves the deliberate release of reflecting particles, typically sulfur dioxide, calcium carbonate, or other aerosols to the lower stratosphere, about 50 to 25 millimeters altitude. These particles scatter solar radiation and enhance Earth orbit, similar to the natural cooling effect observed after major volcanic eruption like Inaugural Lecture 1991, which lowered global temperature by 0.5 for nearly 2 years. Climate model includes SIS and GeoMIP experiment indicate that SIA will offset global warming by several tenths of degrees Celsius if deployed continuously. However, aerosol selection and dispersion strategy are critical. Surface erosion are effective but may cause stratospheric heating and zone duration. White calcium carbonate and diamond dust have been proposed as alternative chemically stable particles. Marine cloud bracking, on the other hand, target low-level marine stratocumulus cloud, which cover about 20% of the surface. The idea is to spray fine sea dust particles into the lower atmosphere to serve as cloud condenser nuclei, thereby increasing cloud droplet numbers and enhancing cloud reflectivity. This method leverages cloud hypothesis and is potentially more localized and reversible than SAI. In both methods, the scientific foundation is added to atmospheric chemistry, related transport and cloud aerosol interaction, fits central to my research on aerosol radiation feedback for West Africa. Oluleye, 2021, Oluleye and Ayodeji 2024. By understanding these interactions, scientists can assess not only the cooling potential of SRF but also its unintended side effect on the delicate balance of Earth's surface, ethical dynamics. At its core, SRM challenges humanity relationship relation. Why its goal is to mitigate climate change impact. It also introduces moral hazard, criticizing that the mere prospect of SRM will deter emission reduction effort, encouraging continued dependence on fossil fuel. Other raise concern about intergenerational ethics. Whether present generation have the right to manipulate global climate conditions that future generation must inherit. These are also equity concerns. The impact of SRM are not uniform. Some regions may benefit from cooling, while others will suffer from disruption or ecological disruption. This asymmetry makes global consent difficult. For example, an SAI development can stabilize this temperature globally, might still trigger growth in the Sahel or other stop track in the Atlantic, African perspective and justice. For Africa, a company research responsible for global emission gets highly vulnerable to climate change. The governance of SRM raises the question of representation and fairness. Africa scientists argue for proactive participation in global SRM dialogue to ensure that regional concerns such as political security and air quality are adequately considered. Ethically, any future SRM research must prioritize transparency, equity, and long-term monitoring. The government must move beyond scientific regulation to improve society concept. Recognizing that the economy is a shared resources, they need to note that no single man should do the sum for all. Mitigation, adaptation, and regulation. Mitigating climate change and improving air quality both to make contamination on reducing cloud gas and greater emissions. The transition from fossil fuel to green energy, low emission sources such as solar, wind, hydro, and bioenergy represent not just an environmental necessity, but an economic and social opportunity for Africa. Green energy reduces dependence on high carbon fuel like coal and diesel, which contribute to both carbon dioxide emission and global air pollution. In Africa, where over 600 million people still lack reliable electricity, renewable energy expansion can significantly advance sustainable development and emission control. Nations like Morocco, Kenya, and South Africa have already demonstrated this potential through large-scale solar and wind farm. In Nigeria, integrating solar deliveries and bioenergy system into rural electrification program reduces the need for diesel generator upon the target largest contributor to urban particulate emission. Studies show that substituting diesel-based power with solar PV system can reduce PM 2.5 and mass emission by 70%, directly improving global air quality. Conclusion. The wonder of weather in a changing world. The story of weather is ultimately the story of life itself. From the earliest breath of the Earth's atmosphere to the modern cause of bad air. Every living organism depends on the invisible movement of wind, moisture, and sunlight. Whether it's not merely a background condition, it is the dynamic habit of the biosphere, shaping the rhythm of agriculture, ecosystem, and civilization. Yet, as humanity technological power has grown, the purity of that atmosphere has been compromised. What was once a self-regulating system now bears the imprint of industrialization, deforestation, and fossil fuel propulsion. The interconnectedness of weather, pollution, and life in itself in every drought, intensified by aerosol, every haze that the sun, and every shower who struggle to breathe in a polluted city. Meteorology teaches us that the atmosphere is a single but not fluid, enveloping the whole planet. Pollution release in one region and into our vast continents, influencing weather and health thousands of kilometers away. Fine particulate matter, water radiation balance, modify ground property, and changes rainfall patterns. Similarly, greenhouse gases swapings and change temperature gradient. The disruptive oceanic and atmospheric circulation that have governed climate for millennia. The interdependence is profound. Weather affects pollution through wind dispersion, rainfall density, and boundary layer mixing. The pollution affects weather through aerosol radiation interaction, cloud microphysics, and changing in atmospheric stability. And life is sustained or threatened by the delicate equilibrium between the two. My research on aerosol climate feedback over West Africa exemplified this relationship. The findings show how aerosol from dust and power burning influence not only air quality but also rainfall, energy forces, and visibility, demonstrating that pollution is not an isolated problem but a climate unifier. Recognizing this unity invites humility and responsibility. The sky we share carry both the blessings of cloud and the burden of our mission. As we gaze upward, we must remember that our atmosphere is fine and fragile and profoundly linked to every breath of life we know. The wonder of weather, therefore, lies not only in its power, but in its intimacy, its ability to connect up from the systemic layers of air and energy. A call for stewardship of the atmosphere. If the atmosphere sustains like the integrated responsibility is to become a steward. Stewardship is more than conservation. It is a covenant between science, ethics, and faith in the future. It calls upon us to use knowledge not for domination, but for preservation. The atmosphere belongs to no nation, yet it is still up. It carries no ban, no border. Its weight carries both seeds and suits. To protect the power collective vision, guided by methodology policy educated as citizens alike. This scientific community provides understanding, policy provides structure, but stewardship provides purpose. In the age of climate change and pollution, stewardship provides more than observation. It demands action, reducing emission, promoting green energy, and integrating air quality forecasting into any policy system are acts of environmental guardianship. Each policy enacted, each sensor deployed, and each lesson taught contributes to this shared responsibility. As we cannot own the sky, but we can care for it. That care begins with knowledge, expand through collaboration, and ensure through education. Stewardship is not the work of one generation. It is the enduring mission of all who recognize that our survival depends on the team prevail that shift the earth from the coldness of space. To be stewards of atmosphere is to see the visible, to hear the whisper of wind and cloud, and to act with reference towards the very air that sustains life. Recommendations. Number 1. The university should establish a center for atmospheric research and climate innovation that integrates environmental science, engineering, public health, and policy. The center will base multidisciplinary projects on air pollution modeling, weather forecasting, and climate resilience. For support organic research using advanced research as problem, Beacon, N, and satellite data. Foster collaboration with national agencies, NIMED, NASA, Nesria, and international partner WMO and WASA. By investing in this hub, the university will not only expand its research visibility, but also nurture a new generation of research scientists, aiming to address African development environmental challenges. Number 2. The state government should implement a state-wide air quality and weather observation effort to monitor pollution level, climate relation, and urban internal. This initiative should include deployment of low-cost air quality sensors across urban and industrial zones, integration with 9 metric stations for localized forecasting and early warning, regular population of air quality disease, and health advisories for public. Number 3, the society must recognize that every citizen is a stakeholder in atmospheric stewardship. Communities, schools, and civil society organizations should participate actively in environmental education and citizen science projects. Action should include integrating air quality awareness in the school curriculum and outreach, encouraging citizen-led data collection using low process and smartphone application, promoting the rural state by reducing local money, conserving energy and adopting green mobility options. Number 4, Nigeria must adopt a comprehensive national atmospheric stewardship policy that unites efforts across sectors of hydrology, energy, health, transportation, and agriculture. Key policy directions should include national emission inventory and central reduction targets, integration of air quality forecasting into national warning system, investments in renewable energy, sustainable transport, and research-based climate adaptation, strengthening the Nigerian Meteorological Agency capability for air quality prediction and public communication. This strategy will align with the UN Sustainable Development Goals SDG 3, 7, and 13, and the African Union Agenda 2063, positioning Nigeria as a regional leader in climate smart innovation and environmental protection. Acknowledgement. All glory, honor, and adoration be unto God, the author and finisher of my faith, whose grace has been my anchor, whose mercy has been my comfort, and whose guidance has brought me to this divine moment. Having begun this journey by His grace, I trust that He will continue to uphold and direct my path. I extend my profound gratitude to the Vice Chancellor of the University, Professor Ayodeji Oluleye, and to all past Vice Chancellors and past and present principal officers, whose leadership vision has steadfast commitment to academic excellence continue to strengthen the foundation upon which scholars stand. My deepest appreciation goes to the Department of Meteorology and Climate Science, my academic group, and to my distinguished seniors and colleagues, head of the department, Professor Ayodeji, Professor Polo, Professor Yepalo, Professor Temi, Ologborisha, Vice Chancellor Olusegun Agagbo, University of Science and Technology, Okutupa. Thank you, sir. Professor Kunjoku, Professor Motosho, and the father of the department, late Professor Adepola, late Baba Ayodeji, Professor J.A. Oluleye, Professor Z.T. Adewa, my supervisor and mentor, Professor E. A. Adebison, and Dr. M.C. Oshe, Dr. R. Maloku, Dr. B.M. Dada, Dr. Ode, Dr. Steve Okubero, Dr. P. Samuel, Dr. Mola, Mr. Ladipo, Mr. Lulu Victor, Mr. Ayodeji Oluleye, and many others whose wisdom, mentorship, and scholarly fellowship have shaped my academic journey. I am grateful to acknowledge Vice Chancellor, Director, Professor I.A. Maloku, and the Deputy Director, Professor Adepola Adepola, and all members of staff for providing effective plan for collaboration, capacity building, and the advancement of knowledge across borders. My sincere appreciation also goes to my esteemed international colleague at DLR for Papa Pepon, Maria Luana, Ross, and Anna for the spirit of scientific partnership, collegial works, and shared pursuit of excellence. I deeply appreciate the School of Art and Political Sciences with past day professors and colleagues for personal environment where scholarship thrives and ideas are launched. I also thank all my students both at the undergraduate and postgraduate level. They have really contributed immensely to my success story. I extend my profound appreciation to my parents, Mr. Julius Oluleye and Mrs. Esther Oluleye, who are here seated today, to J.B. Oluleye, and to my beloved friends and friends from around me and Nigeria. Your presence, prayer, and unwavering support remain a constant source of strength and pride. I thank the members and leaders of my church, the God Great Mission International People's Assembly, West State, and every led by the Archbishop Pastor, Dr. Richard Adesoji, who is also seated here today. Thank you, sir. And the resident pastor, Dr. Dili Ilori. Apart from, I'm feeling gratitude to my wife and children, whose love, patience, and sacrifice, and quiet strength have sustained me through every season of this journey. I'm also grateful to friends and well-wishers who I cannot mention here for lack of space and time. Once again, I return all glory to God Almighty, for truly, except the Lord build the house, the labor in vain, they have built it. Thank you all.
may be seated. Shall we give the lecturer another round of applause? As our custom is in the university to acknowledge the presence of everyone who is here, but specifically I would want to recognize some individuals. I recognize Professor Debo, former Vice Chancellor of the University, and his Amir wife. You are welcome. Our brand new Vice Chancellor, Professor Philip, Professor Efo Ayodeji, Deputy Vice Chancellor, representing the Vice Chancellor of the University of Science. Also recognize Professor Mukaga, who married Mrs. Zena Falai, former deputy librarian. You are welcome. We should label that seat. Professor Moses Ayodeji, former member of the government. You are welcome. Professor Martin Bidoye, immediate past president of the Nigerian Institution of Surveyors. You are welcome. You can also see Professor Yekin Anifosh, former chairman of the conference. You are welcome. You can see others who I will not mention their name. You can see Mrs. Abiodun, headmistress in Huge Primary School. All staff of St. Jude's Anglican Primary School. All teachers from Federal, you are recognized. All relatives of the inaugural lecturer from the direct, brothers, siblings, can be recognized. You are one of the students. You are welcome. For one of space, we will not be able to mention everyone's name. The acknowledgement is short, and the limits of that movie. I think himself is not. The Baba of the department, you are welcome.
James